Well, I thought I was going to be able to finish all in one video, and I'm sorry for the abrupt transition from one thing to the next, but I do have to keep on going. And this is part two, talking about derivatives of non-polynomials. And yes, it is still your boy, Algebra, coming to you live and direct from the studio. So, where I left off was talking about what you get from y equals the cosine of x. And we were using these blue lines over here on the second graph to kind of show the trend that is being set by the instantaneous rates of change. We said that it started off at 0 and then it started going down, decreasing function, zeroes back out, and then becomes an increasing function. Yes, we have different points of concavity along the way, but the important thing in this particular graph is that you understand it is creating that same wave again. It is a sine wave, but this time, because it starts on the way down instead of up, it is the negative sine of x. This is going to be your dy dx. And so as we continue to build this toolbox full of derivatives, you have now added two of them to it, the trig. And there's one third piece of trig that you need to know. I'll skip the proof on it. I'll skip the graphing. You need to understand that the tangent is going to become dy dx equals the secant squared of x. And as I mentioned before, all of these could potentially have the chain rule inside of it. Think about it this way: you have to deal with the part that is inside, and if it's not just an x inside of the sign, that means there's a chain rule involved. Anytime that you see parentheses, you have to do the chain rule. So let's go ahead and grind through a couple of these problems. I'm going to give you the first one that has a chain rule, but then the second one, I'm going to hit you with a double chain. We'll see if you remember how to deal with that. I would like to give you first y equals the sine of x. Actually, no, not the sine of x. I'm going to give you the sine of e to the x. So what that tells you is that, yeah, you have a chain rule involved here, but that sign on the outside is not going to be changed. It goes straight to cosine of e to the x. That's your outside. But now you need to include the derivative of the inside, which is just e to the x. Your final answer is exactly what we have right now. Done. So how can I step up the level of difficulty? Well, of course, I could start to add extra pieces to it, and that's going to be the main thing that can change. How about a 2 times the tangent of 5x squared? This time, again, the tangent's not going to change. That 2 that's in the front is just a coefficient. It's going to stay there. 2 times the secant squared of 5x squared. That's your outside. So now you need to deal with your inside. It's not good enough to change just your outsides. You also got to address what's happening on the inside. That's how every great makeover starts. Yes, they change the outside, they change what the person looks like by putting a little bit of makeup on, giving them a new outfit. But if they don't change the problem that existed before, it's going to resort back to the old ways. You have to address the inside. 10x addresses the inside of this function. So this time, I'm going to give you a whole lot more things to deal with in this problem. And hopefully, you're not intimidated by it. Let's go with a negative 3 times the cosine of e to the 6x plus 3x to the 5th, all as an exponent. I'll put it in parentheses to help you out a little bit. So again, there's a whole lot of things happening here. First of all, you have trig. You have a coefficient. You have an e to the something. You've also got a polynomial inside of that. So there are multiple levels in this problem. and we have to address them all. First one, let's talk about the outside. Then we'll talk about the inside. Then we're going to talk about the super inside. And I think you should be able to identify each one of these pieces already. This is where we're going to talk about the -3 times the cosine part. The inside was the e to the part. But that super inside is just the polynomial that was the exponential. So all three of these things need to be addressed. And we're going to multiply them for a final answer. Here's what I should have. The outside becomes the sine, 3 times the sine, and nothing on the inside has changed yet. We have only addressed the outside right now. The inside doesn't change. But we deal with the super inside as well, which becomes 6 plus 15x to the 4th. Those three pieces all together become your final answer. This is completely done. So how you like them apples? Now we have trig, we have exponentials, we have logs, and we still have the power and chain rules on top of everything. Let's go ahead and write all of those out in a list, and then you're going to have some homework tonight in the book. I would strongly suggest that you get some practice at this. It's the last major piece that we have to deal with for this school, or for this semester. So you really need to know it before we get into talking about finals and such. Our list. We have a power rule. We have an exponential rule. We have the natural log rule. Then we have the trig. And those three trig rules, there's one for sine, there's one for cosine, and there's one for tangent. These are the derivatives that you are responsible for knowing. I'll give you an example, a simple example that uses each one now. 5x to the 4th. An exponential, if you see it, you automatically have to do it. E to the 7x plus 4. A natural log question would look something like ln of 11x squared plus 4. I don't know why I keep on using these 4s, but we're going to roll with it. The sine would be something like the sine of 4x to the 17th. The cosine, again, it can be whatever I feel like putting on the inside of it. Whether that's an E or something that resembles more the power rule type of question. And I could talk about the tangent. Using those rules, the first one, you just take the power down, multiply it times the original coefficient, and reduce the power down by 1. Final answer, 20x to the 3rd. For the exponential, you take that same exact thing as it currently exists, then you multiply it by its chain rule derivative, which is just 7. Final answer, 7e to the 7x plus 4. The ln part, it just goes to the denominator, 1 over 11x squared plus 4. However, you need to do the chain rule on it. So it's going to have a 22x on the top. Final answer says 22x over 11x squared plus 4. Cannot be simplified at all. Cannot do anything to any of these three problems. These are your power, exponential, and natural log rules. The last three rules that you have are all related to trig. Trig says sine becomes cosine Inside has not changed, but I do need to do the derivative of the inside, which is going to be 68x to the 16. Done. For the cosine, it becomes the negative sine of e to the x. But don't forget to do the derivative of the inside as well. And finally, the tangent. I'm going to get a secant squared of x. And I would do the derivative of the inside, but what's the derivative of x? It's just 1, so it kind of took care of itself this time. I would strongly urge you to make sure that you get some practice with these questions. If you don't, you're coming back to class when I return, and there may or may not be a pop quiz waiting on you. These are the practice problems. Bon Shones, good luck. I have nothing but faith and appreciation for all of you. Peace.